We are doing a two-part reaction. Number one instruction. Things are on fire in this classroom. Small things, but small fires get big if you are not responsible with them. You cannot move from where you are standing or where you are sitting. You cannot come up to me. You cannot throw things. You cannot blow on the fire. You cannot do any of the insane things that might come across your mind if you see fire in a classroom and we're having fun playing around doing experiments. Is this clear?
Yes.
All right. If you of the classes saw this happen on YouTube, seeing it happen on YouTube is cool. Seeing it happen in real life is much cooler. We are not going to start with our fire reaction. I mean, it's happening right now. There's chemical reaction going on right now, right?
Yeah.
Combustion. We know a chemical reaction is when you change something and it can't be changed back. When those two candles burn out, they just won't be there anymore, right? Yeah. Gases are coming up. You can do this. You can feel the heat coming up. The heat is a sign that, elements are changing, bonds are changing, different chemicals are happening. You can see the wax melting, which is what kind of changes the wax? If you can change it back, it is what? Physical. Yeah, if I blow this candle out, the wick will be chemically changed. The wax will be physically changed. 20 minutes from now, it'll look exactly the same, just in a different position. Yes?
Then why doesn't fire go out? Like if there's a fire in your house and all the rooms are shut, why doesn't the gas that's blowing out, why doesn't it kill the fire?
Good question. It can. But
It can get through the
yeah, it'll draw air through the ceiling. Like that ceiling's not solid, right? That fire is sucking up oxygen and it's rearranging the molecules and putting off carbon dioxide. The carbon from the stuff that's burning, the wick, and the oxygen that's getting sucked in are fusing together and putting carbon dioxide. That's why you have to get close to the ground during a fire. Or carbon monoxide is one of them too. That way the carbon monoxide is lighter than the air, so it floats up, you crawl across the ground, you don't suffocate. But it's constantly pulling in more oxygen from outside. Yes, sir?
And also, if there's no oxygen, you cannot have a fire.
That, sir?
Like when my mom called a fire, she was burning trash. What she did was to put it out. She put one hand over each spot of the fire and put it out.
That is an exceptionally painful way to put it out, but I bet it works. We are going to do exactly that. We're going to deprive that fire of oxygen by using another gas. They have here is baking soda. Just 55 cents at the Dollar General. The Dollar General just got a free advertisement on our YouTube page. Vinegar, $2 at Shop It Safe. Vinegar and baking soda, when you mix them together, a very big reaction. They're very, very reactive.
Oh yeah.
What gets created, do you know? Very commonly used in fire detectors.
Gas.
Or fire extinguishers.
I forgot.
Carbon dioxide.
Oh, man.
Carbon dioxide doesn't burn. You can't burn it. You can only burn oxygen. So, when we mix these together, and I'm going to mix them together a little bit at a time, because I don't want to spill my carbon dioxide. What is happening is that baking soda and that vinegar reacting together bubbles. Those bubbles are the atoms and molecules rearranging. Instead of vinegar molecules and baking soda molecules, we are getting carbon dioxide molecules. Can you see them?
I
Looks like milk.
It looks like milk at the bottom. But can you see the carbon dioxide?
No.
No. It's gas. It's not a gas that has a color either, just gas. Is it in there?
Yeah.
Yes.
Yeah. I mean, we assume it is. Like a lot of science, we can't prove it right away. Just be like, science, it worked, yay! No, we guess it is. Carbon dioxide is heavier than air. It sinks. So the air out here, we're burning it right now. The carbon dioxide in here is not coming flying out because its molecules are heavier than the molecules that are floating around us that we're breathing in. But what should be able to happen is we can pour it, because it's a fluid. Anything that forms to the container that it's in is a fluid. So this carbon dioxide, it's not a fluid like this is a fluid. But gas is a fluid too. That's why if you blow up a balloon, it takes the shape of the balloon. If you tie that balloon into a little monkey, the air molecules on the inside are monkey shaped. If that was a water balloon and you tied it, other than being a desperate risk of being covered in water, you could tie a water balloon into monkey shape too. So this fluid gas should be able to pour it. Now, if this is working, you start to see the candle flames dance around a little bit. That candle flame on the bottom is a lot smaller, isn't it?
It's like soda.
It does. It's that same release of gas kind of thing. Notice I've got it in its own separate container.
Yeah.
Never done this before. I'm assuming it'll work, but I'm not going to assume that I'm not going to, get carbon dioxide, vinegar, baking soda mess all over the place. You guys have met me. You know how it rolls.
Oh my gosh, it's
Magic.
It's not magic, it's science. It's better.
Close. Oh no, smoke.
Only magicians could do magic. You guys could do this experiment. It cost you about,
Whoa.
$2.
I don't know, $2 tops. Now, why did the bottom candle go out and the top candle stay lit? Now, the flame on the top candle is a lot smaller. Sir,
Because the carbon dioxide sinks.
carbon dioxide sinks. So this candle on the top is still getting oxygen. Down here, we've got a lake of carbon dioxide down here.
Put it over towards that.
I can see the.
Yeah, you can kind of see.
Yeah, that flame is getting real small. It's having a hard time pulling in more oxygen molecules.
It's kind of like, no, don't die.
Smells very pickly up here.
Yeah, it does. Yeah, it smells. Guys, you can smell it because it's so cold. It sounds like you're pouring something with your mouth.
It does. It's fighting me. You can see that flame flicker.
It's gone.
You can see the gas.
You can't see the gas. What you can see is... Oh, we're not done yet. Yes, sir. Don't stop pressing.
Did we just get started? Did we just get started?
Yes, we did.
What if you just pull it off that?
Probably find something cool on YouTube. Cool chemical reactions on YouTube. Now, inside this, we got a box of not breathable gas. So if you stuck your face in there and went, chances are high you would also go. You can't breathe that. But we know it's there. Doesn't feel any different. Just a gas. So, when I take our candles out, and I do that, feel all that gas hit you? No, it just mixed in with the air molecules. This gas that is in this container is around us all the time. Plants breathe this gas, and they give off oxygen. That's why we like plants.
I bought this.
I know everybody on this half of the room is like, ah!
Except me.
Yeah, you a little.
Do that thing again.
I might. Now it should be empty, right? Or it should be at least filled with air. That burns. So,
What was that?
shoe squeak.
I heard a whistle.
That was a shoe squeaking on the ground. Take a fire. Should light again, right?
Yeah.
No.
No.
No, it's not going to.
Yep.
Wow.
It goes just
That's going bigger.
Yeah, very big.
Little one's gonna have.
It's getting bigger than
Isn't it higher?
It's full of air now. We dumped out our carbon dioxide. If you get a fire extinguisher and you spray it, or if you've ever seen anybody spray a fire extinguisher, it shoots that white powder. That white powder contains high volumes of the gas that's created with vinegar and baking soda, and you spray it across the fire, and that powder sucks all the oxygen out of the fire and kills it.
Awesome.